Please welcome to the stage Director, Azure IoT, Sam George.
Good morning, everyone, and welcome to Ignite Day 2. Thanks for making your way over to this location. My name is Sam George. I'm Director of our Azure IoT efforts, and I'm here today to talk about all of the wonderful things that customers are building on top of Azure IoT and Microsoft IoT, as well as all of the rich capabilities that we're delivering. So you just saw a video of a lot of the companies that are already benefiting from IoT. What's interesting when you look at this is that for them, the Internet of Things isn't a technology revolution, it's a business revolution. It's enabling them to transform their businesses in ways that weren't possible before. And there's a variety of improvements that are happening across all of these companies and industries. From Hershey's, which has taken their Twizzlers production line of licorice products and transformed those, saving over $500,000 a year in production. They've even started a consortium because it turns out there's a common pattern as you're extruding these materials, whether you're extruding licorice or whether you're extruding electrical lines. There's a common pattern of optimization that can be done. ThyssenKrupp Elevators, which has dramatically reduced the amount of servicing they do on their elevators. Or Dunovnet in Australia, which is revolutionizing agriculture, reducing the amount of water consumed by up to 20% and increasing yields of the crops by up to 30%. Now what's interesting is when you look at these IoT solutions, they all follow a very common pattern. You have things that are being remotely monitored. And this is often not the devices themselves that you're interested in, but it's something that the devices are monitoring. There's insights that you gain, and there's actions that you take as a result. And so this common pattern repeats itself again and again over in IoT solutions. Sometimes those actions are to trigger business process integration. Sometimes those actions are to trigger actions on the device. But either way, you see all three of these things present. Now, to handle the billions of devices sending trillions of messages, a few years ago, we introduced Azure IoT Hub. Azure IoT Hub is our cloud gateway for connecting and managing all of these devices. So when you look across all of these industries, you see this common pattern repeated again and again. And it's not just that simple pattern, it's also an architectural pattern that you see in the services that are deployed that are being used. And whether it's a connected oil rig, whether it's a smart meter, or even oyster beds that are being measured with remote sensors that are measuring the salinity in the ocean that test for purity so that you can harvest oysters with high confidence. Whether it's vaccines that are being monitored as they travel from production to the hospitals to ensure purity and that they haven't undergone any unnecessary vibration or temperature disruptions. All of these patterns are being applied again and again in IoT, where you're sensing the physical world, where you're gaining insights and you're taking actions as a result. And all of these companies and thousands more are already transforming their businesses using Microsoft IoT. So today we're going to cover what that means. What are the solutions that we enable? What are all of the different parts of those solutions? And how can you benefit right now? Microsoft has the most broad set of portfolio of services, solutions, and products for IoT of any vendor on the planet. We provide everything from rich connectivity to devices, to edge support, to device management, to data and analytics, to business process integration and visualization, and solutions built on top of that. But most businesses don't start there. They don't start with all the constituent parts. They start with a solution. Years ago, we learned that IoT solutions were slow to get started because it required a lot of expertise to get going, and they can be quite complicated. There's many services that are involved in an IoT solution. So we introduced a couple products, and we have two different approaches to IoT solutions. The first, which we've had in market for several years now, is the Azure IoT Suite. The whole idea with the Azure IoT Suite is to enable a solution to be provisioned in minutes. Something that used to take weeks or months, we can now provision in minutes, including all of the different services that are involved in an IoT solution, a default application, and that application is open source with no restrictive licensing, so you can simply take it and customize it to meet your needs. And the great part about that is it accelerates your time to value. It's really geared for custom solutions so that you can customize it in any way you need fit. And then this year, we announced Microsoft IoT Central, which will be in preview soon. It's a fully managed SaaS offering that requires no cloud solution development expertise. And the reason we're doing this is we're seeing a lot of the same patterns in IoT. And so we're able to enable a configuration-only, no-code solution that enables these patterns, that helps companies that where IoT was out of their grasp take advantage of IoT. The best part is that both of these solutions use the exact same Azure services. So as these Azure services, from IoT Hub to Stream Analytics to time series insights to machine learning to logic apps, as these services continue to improve, these solutions naturally accrue those benefits as well. And so as we develop new capabilities in IoT Hub, those are available in both our SaaS solutions and in our PaaS solutions. Now, the Microsoft Azure IoT Suite is really about several patterns that are very, very common. One is remotely monitoring devices and being able to sense its presence in the real world and receive real-time telemetry from it. So our remote monitoring solution was one of the first ones that we did. Also predictive maintenance, and recently we announced Connected Factory. And Connected Factory is for connecting to on-premises OPC UA-based devices and to be able to gain insights from them and pull data from those in ways that were never possible before. And we're thrilled to announce this week that we're updating our remote monitoring service. It includes a beautiful new UI built on a very extensible platform. And so what we've done is we've refactored the remote monitoring pre-configured solution with a new microservices approach. And we support both .NET and Java, so that if you're a Java developer, you have a first-class experience with microservices in the Azure IoT Suite. We also use a very flexible UI framework, React, and all of this, again, is open source, so that it's very easy to customize to meet your needs. Because we're using that microservices approach, if you simply want to replace one small part of it, it's very easy to do that. We also include a new troubleshooting and remediation dashboard so that you can see and monitor your solution health and take actions to correct it. And we have a bunch of great new features, including a new revised rules and workflow and device management support. So all of this is open source. All of this is something you can simply take and customize to meet your needs. And there's also Microsoft IoT Central, which will be available in preview soon. Microsoft IoT Central includes all of the rich capabilities that that the Azure IoT Suite has, except it's fully managed. We wear the pager, we secure the solution, and we scale it. You simply add devices to it, and we automatically take care of the solution for you. Now, Microsoft IoT Central is geared towards 3 different types of users. The first is builders, and these are the ones that take Microsoft IoT Central, which is a horizontal offering, and produce vertically specialized applications, be it remote monitoring, fleet management, track and trace, or even monitoring those vaccines. You simply customize the application and produce a template. That template includes the full device model, so you can specify which types of data are coming from the device, which state transitions the devices go through, which telemetry that they send. And you can set rules over that telemetry, and so you can monitor for those and automatically trigger business processes. Like, for example, sending emails and SMS and opening Salesforce and SAP records. And all of this you can save as an application template. That application template can then be kept private, or it can be delivered into the Microsoft AppSource SaaS marketplace for customers to go and provision. Ultimately, administrators go and provision Microsoft IoT Central applications and set up users that have access to it and what their permissions are, as well as maintain the identity and control identity of everyone that's accessing the system. And finally, there's operators, and operators are the ones that actually operate on a day-to-day basis, these IoT solutions. And so they have work lists that they can work through, they see alerts and rich dashboards, and they can customize it to meet their specific needs and to look at just the devices that they care about. So the best way to explain all the great things that we're doing with IoT solutions is to see an IoT solutions from one of our customers in action.
The right organizational culture can shift mindsets, fuel employee engagement, and foster creativity. But CEOs are seeing a lot of empty space in their offices. Up to 46% of an office may go unused every day, while only 13% of employees are highly engaged in their work. As companies race to move forward, their offices are stuck in the past. Steelcase is an industry-leading manufacturer and authority on the places where people work. Together with Microsoft, they're developing the smart and connected workplace. Integration with Office 365 improves data accuracy, while the Steelcase Workplace Advisor relies on Azure IoT and advanced analytics for real-time 24/7 reporting with enterprise reliability and security. Together, Microsoft and Steelcase are shaping the future of the smart and connected workplace.
So it's my privilege to welcome to the stage the CEO of Steelcase, Mr. Jim Keane. Jim.
Thank you. Morning, Sam.
Welcome. Thanks for joining us.
Good to be here.
So what were the challenges that you set out to solve with the solution you've developed?
Well, Satya talked yesterday about the modern workplace, and so let me just talk about that first, because that's really the root of the challenge. So we're all still working largely in the not-so-modern workplace, so we all know this very well, cubicles everywhere and private offices, and really that's a workplace designed around process. How do we optimize for process flows? And as work has changed, as automation has taken away a lot of the process work, as AI comes along and eliminates a lot of what's left, the workplace is becoming centered on knowledge work. And as that's happened, the workplace hasn't necessarily changed. So we're trying to do knowledge work in a space that's designed for process work. And that's why you see some of the problems, and some of the problems are really a paradox. As the video said, 46% of space goes unused in the workplace. And yet, a lot of people say they can't find the space they need to work. They can't find a place to concentrate. They can't find a place to meet with colleagues on short notice. They can't find a place to be able to work on tough problems as a project team for long periods of time uninterrupted. And when you're looking for a place, you end up spending a lot of time wandering around trying to find one, because the workplace is very dynamic and it's constantly changing.
Sure.
It's like the parking lot problem. You pull into a parking lot, you know there's a space there somewhere,
right,
but you just don't know where it is. And we believe that even with the limited data we have around utilization and workflows, that more data could be very helpful as people try to make sense of this shift from the old way of working to a new way of working.
So how are you seeing technology and space coming together to empower people in the workplace?
Yeah, so technology and space, furniture, have always been connected. Your world and our world have actually referenced each other. The reason cubicles are the way they are is because of mainframe computers and desktop computers, and the CRT needed a place to go. As laptops came along and mobile laptops, and now all the range of devices, furniture continues to evolve. So it's always been true that technology and space were connected. But we see opportunities to do that even more. So we all own technologies, use technologies at work, and yet we only use a small fraction of what these technologies are capable of. And the trick to getting it used more completely is to change human behavior. But changing human behavior is hard. So space is actually really good at changing human behavior. If you move people from one space to a new space, you break a lot of those old patterns of behavior, and you have the opportunity to create new ones. And we've already seen that through some of our own experiments. A change in space can change the way people use technology they already own. We also see that technology can help us understand what's going on in space. It used to be easy. If you're a facility manager, you just walk around. You knew where people were assigned, where their desks were assigned. You knew which conference rooms were available. You could walk around once a day and get a pretty good sense of how the space is being used. But in today's dynamic environment, the way the space is used at 9 o'clock in the morning can be very different by 10 o'clock.
Sure.
Technology has the opportunity to give us more information about how space is being used so that we can reduce the amount of spaces that are in oversupply and add more spaces that are in high demand. And we've really not been able to do that until now.
So now that you're collecting all this data from space with the solution, what are some of the problems that you can solve with that?
Yeah, so the first problem has to do with users. And maybe I'll start just by talking about some of the technology we're deploying. Sure. So behind the Steelcase Personal Assistant and the Steelcase Workplace Advisor is Office 365. It already is rich with data about the people in the organization, the rooms in which they work, the calendaring, and so on. What we've never had is information about how space is really being used. You know the room is booked, But how many times have you walked up to a room that's booked and there's nobody there? Now, is that room really available or not? So with the addition of sensors in the workplace, we can actually begin to monitor real human behavior in real time. So layering actual human use, human behavior, on top of the information that's in Office 365 gives us the potential to start to solve some of the problems people are facing. And the first of those problems has to do with users. So we know that users, and you think of yourselves, imagine it's 10 o'clock in the morning and suddenly you have to meet with some of your colleagues. In the old days, that was easy. Your colleagues sat in predictable places. They often sat right around you, and the room you would meet in would be right here. But today, people are all over the place. They're in informal areas, in cafes. They're traveling. You can try sending them a text message. They might be on an airplane. So we spend an awful lot of time just on the basic idea of how do I find my team? And once you find your team, then you got to figure out what's the right place to meet and how do I find a room to meet in. So we just wanted to start with those two simple problems and take all the data between the sensors in Office 365 and come up with an app that would make it easy. So we'll just demonstrate that here. So the personal assistant opens and it really only does two things. It helps you find your teammates and helps you find rooms. Let's start with teammates. So you have a list of favorites. You just select the various people that you work with most often and say those 3 people are the ones you want to meet with. The app searches for them and discovers that 2 of them are here in town, in Los Angeles, say, and 1 of them is traveling. So right away, the app knows if you want to meet with these people in a physical space, you need to select a room that is enabled with video conferencing. Okay, so now you hit that button, and it offers you a variety of spaces, 3 spaces here that are all the right size for the kind of meeting you're having, and all have video conferencing. Maybe you're familiar with that room. You book it for the length of time you need, say 60 minutes. You hit reserve, and it reserves the space. And then continuing in the workflow, you can send invites directly from the app to the people on the team, so everybody knows when the meeting starts, when it ends, and what room it's going to be in. And that's, you could have left the app to go into Office 365 to do the same thing, but this is a way of doing it as part of a workflow that's designed from end to end. So from looking for your teammates, finding rooms, booking the rooms, sending the invites, it's all done from within the app. Now let's say you're in the meeting, and let's say you've been in these meetings, it's going great, you got 15 minutes to go, you got a quick reminder from the app, you have 15 minutes to go. And maybe you want to extend that room reservation.
Yeah.
Most of the time you don't even know if the room has been booked by somebody else. So you're getting to the top of the hour. Can I extend that room reservation? So again, right from the app, it reminds you 15 minutes ahead of time. If the room is available, it offers you the option of extending for additional time. Another interesting thing is that you get to the end of a meeting, and sometimes you're in a room, you'd love to tell somebody about things that worked and didn't work, but you have no way of doing that. In this app, you actually have a way of rating the room itself at the end, and let's say this one was just mediocre. Don't worry, IT, they love the technology, but the privacy wasn't so good. So you can send a note right from the app that says, this room would be better if we had some frosted glass or some way of having a little bit more privacy. So remember that piece of data, because it's an important piece of data for something we also developed, which is called Steelcase Workplace Advisor.
That's great. And then all of these rooms are connected through sensors using Azure IoT built on top of what kind of data are you collecting? What kind of volume of data is this processing?
Yeah, it's an enormous amount of data. Just imagine these sensors in every conference room to start with. And then later on, they go into the in-between spaces, cafe areas, other places that people meet informally, individual spaces, both reserved and unreserved, assigned and unassigned. And then think about that for every floor of the building, every building on your campus, and every campus in your global campus.
Sure.
And there's a ton of data.
Quickly.
This would not have been possible without Azure.
Great.
It also raises concerns, though, because customers are quite concerned about things like security. In fact, there's a lot of other apps that have been out there before that are kind of one-off apps that have their own databases. And clients ask serious questions about what's going to happen with my data. Information about who's meeting with whom, about what topics, at what time, is proprietary information. You don't want your competitors to know about that. They're also concerned about reliability. They don't want these things breaking.
Right.
And they want it to be scalable. So it's great that it works on one floor or one building, but if I do want to extend it, it's why they have so much confidence when we tell them that it's been built on the Azure platform.
Cool.
Also related to this is security, personal security and personal information. Individuals have real valid concerns about their own information and how information about where I am and how I'm working might be used by others. We intentionally chose right from the start to do the personal location tracking as an opt-in. So each individual has a choice of whether they want to participate or not.
That's great.
And if they get value from the app and they feel that their colleagues are getting value from them being available in the app, then they'll choose to use it. And if they're not, if privacy is more important to them, then they can make their own choices. But we think people will generally use it because of the simplicity and the value.
That's great. It's very powerful. So now that all this data is being collected, how can building managers benefit?
Yeah, so building managers are also awash with data, but the data is not in a form that they can really use for their normal workflows. So we've worked with facility managers and real estate people for a long time. We understand the kinds of problems that they want to solve, and they want to get a better sense of this building. As I mentioned before, walking around just doesn't do it anymore.
Yeah.
So we built, off the same database, built an app for them. So when the facility manager opens their app in the morning, they get a dashboard that shows things that they choose to track. Things like total building utilization or energy consumption. These are all things that are available in their building systems, but now we can put it on their start of the day dashboard. So one of the things that building owners and managers, facility managers are often dealing with is, what do I do when a team needs something special? It's one thing to reserve a room for an hour or a day, but what if a team needs to be together in a space that's dedicated to them for a long period of time? They want to get a better picture of how their space is utilized so they can assign them a space without being highly disruptive to the rest of the organization. So here they can go into the app and select the floor and see a heat map of use. Blue is heavily used spaces and red are spaces that are hardly used. And then they can see the details behind each of those spaces to make a choice about which space would be perfect for this team, complete with data about each of those spaces. Another thing they often are trying to do is compare utilization within space. So here, let's take two spaces, about the same size. You would think they'd be used about the same amount. One's called Whitney and one's called Shasta, just two rooms for individuals to have heads down work. And you discover that Shasta is not really being used very much. So you can go into the app and look at a comparison of the two spaces side by side. So remember, Whitney on the right is the one that's used more, and Shasta on the left was used less. Now I can look at that and say, well, I can see some differences. I can see that Whitney has a height adjustable table, for example. I can see that it has more ergonomic performance and it has better lighting. So maybe it's one of those factors that could help Shasta be more heavily used. But let's go a little deeper. Maybe I can get more information about Shasta and what's holding it back. So going deeper on a particular space, you can see the utilization over different days and over different times of the day. But I can also see this input from users that we captured earlier. What are people saying about the space? People who've actually used the space, what are they saying about it? And what can I learn from that might guide my next decision? Then the app suggests options. Options for ways you can improve the space in particular ways. So for example, let's say it's privacy, and you're trying to increase the privacy performance of this space. You can add an architectural film that just adds kind of a layer of frosting. It's very inexpensive. An inexpensive layer of frosting to improve privacy, and we've seen that this has worked in the past. Now, facility managers would like a little bit more data about that too, because we're still kind of guessing, is that really going to work? So over time, the app begins to learn about what works and what doesn't work. And as it suggests different solutions to you, it can use predictive analytics now to say, in the past, when we've added privacy to a room like this, we've seen utilization go up by a certain amount. Or let's say we've improved ergonomics or added a height adjustable table. We can see that utilization in your experience and in our collective experience, the Steelcase, has had that kind of performance. Also in the area of learning, something we're really intrigued by is, what if the app gets smarter as it relates to the recommendations on space? So that person who cared a lot about privacy, they could go in and add a filter intentionally that asks for space that has more privacy. But a lot of times we don't know ourselves that well, and the app over time could learn about preferences that the person has just from the ratings they give that could make us smarter about the recommendations. So people who tend to always add comments about privacy, we could just automatically suggest rooms that have more privacy. Or there's people in the office that are always too hot or too cold, and don't you wish that they could find each other? You know, like this hot room could be found by the people that prefer that, and so on. It would make it a lot easier for facility managers and real estate managers, rather than trying to optimize every space, make it perfect for everybody, which is really impossible. We instead help users make better choices. So they're picking the spaces that are actually perfect for them.
So one of the things we love about IoT solutions is as you deploy them, you start to learn things that you've never learned before, and that often leads to further insights. So in your trials and pilots of this, what are some of the things that you've learned from early adopters?
Yeah, so we did a number of alpha sites first, and a lot of those were on our own spaces,
Sure.
because you like to start at home.
Yeah.
And make your mistakes where it's not so visible. And then we began working with clients, and we've had a lot of great beta sites with clients. One of the most challenging ones, and one that we actually asked ourselves if it's really a good idea, we decided to do one with an architectural and design firm in their own space. And I thought that was a tough test, because these guys are really dialed in. I mean, they designed the space, they know the space very well, they're experts at space, so they're observing how they use their space every day.
Sure.
You know, how could we, if the app is good, could it add another layer of data that even architects and designers would find to be relevant? So we went to work on that. We installed the sensors. We gathered data for a while, and we came back to them and reported the results. And I was happy to discover there were some insights. So, for example, there was a conference room that holds 12 people, and they knew that conference room was one of the most heavily booked spaces that they have, and the data confirmed that. But what they didn't know until they looked at the data is that a lot of times that room is booked not for a 12-person meeting, but for one person to make a phone call. And that happened a lot. Like a high degree of utilization of the space that's in high demand is people who just really want a phone booth. And so they realized they just didn't have enough spaces like that. They needed more spaces where somebody could go and have a private conversation. And probably everybody here can relate to that when you're trying to find a place to make a phone call. So by creating more spaces that do that, you're able to free up a space that's in high demand. And we find this a lot. A lot of the interventions that are required to improve utilization of an underutilized space don't cost a lot of money. I mean, sometimes it's furniture or architecture, but a lot of times it's things like architectural film or a change in use or just the reorientation of the furniture can change human behavior. We've never had this data before. We see this as an opportunity to take it really to a whole new level.
That's great. So when's this all available?
Well, all the capabilities you saw there will roll out through a series of waves. The first wave is available now.
Awesome.
And then every 3 months, we'll launch a new wave. So we'll continue to add to the performance of both apps.
It's great. Well, it's exciting stuff, and it's a beautiful, beautiful product you've built. And we're so excited to have you as a partner.
It's been great for us to work with the Microsoft team. Thank you for all your support.
Thank you very much, Jim.
Thank you.
Take care. That's such a great example of how IoT can help marry the physical world and the digital world and the things that it unleashes once you have. So let's start to look at what's under the covers. As you get into that things and insights and actions paradigm, what's involved in each step? When you start thinking about things, it's about building things, connecting things, and ultimately managing things as well. When you look across all of those different patterns, all of those different solutions, the IoT device needs for each one of those is pretty different. And what we found is that there is no one IoT device that fits all. Instead, there's a variety of them. We've been busy over the last several years certifying devices. We have a certification program that takes the guesswork out of it for you. So you can be sure that these devices work out of the box with Azure IoT and work seamlessly connect. We have a device catalog with over 580 devices from 200 partners, and it's growing rapidly, 250% growth this year alone. So what this device catalog does is it enables you to filter and search across a variety of things, from all of the different Linux and Windows operating systems to even real-time operating systems, to different protocols that it supports, to different peripherals that it supports. All of this is available in the Azure IoT device catalog. Microsoft also provides Windows 10 IoT. And Windows 10 IoT is a phenomenal operating system for IoT that includes built-in security and enables you to go faster to market. It includes a rich set of device management capabilities that makes it easy to manage and remotely lock down IoT devices. There's a great set of capabilities, and one of the things we're most excited about is that out of the box, it supports Azure IoT Hub, as well as our new Azure IoT Hub device provisioning service, which I'm going to talk about in a minute. And it includes that rich capabilities. It's already integrated with Azure IoT's device management. So if I want to remotely lock down a network, or if I want to remotely manage something on the device, it's very, very easy out of the box to do that with the integration that we've done. On the topic of connecting things, the Internet of Things demands connectivity for billions of devices sending trillions of messages, and we're very much up to the task. When you look at that Things, Actions, and Insights thing, we have this Cloud Gateway Azure IoT Hub that's been in market for several years now, and it enables 3 important capabilities. The first is bidirectional connectivity, and this enables billions of devices sending trillions of messages to connect to the cloud in a secure and scalable way. It supports all of the popular cloud-based protocols for connecting IoT devices, from HTTP to AMQP to MQTT. It enables you to send telemetry, receive commands, and even perform device management capabilities, all from a central location in the cloud. We've also focused on enterprise scale and integration to enable those billions of messages to be sent and to be able to scale your solutions up and down. We have wonderful convenience features such as message routing that can automatically interpret messages as they come in and split them and send them to different back-end systems. We have rich support for Azure monitoring, so you can monitor all aspects of your IoT solution, device health, and device state. And then end-to-end security. Microsoft has a long history in security, and we are applying that to IoT to keep IoT safe. We support per-device certificates, the ability to enable or disable devices, and we only support TLS protocols for security and IoT. We support X509 certificates. We can whitelist and blacklist IP addresses, and we have a variety of capabilities that keep your devices safe. Let's talk about device provisioning. Once you have a solution set up, provisioning devices can often become the bottleneck. Because right now, device provisioning is a very manual process. 8 years ago, when you went and bought a mobile device and you walked into a store, someone had to take it out of the device or out of the box, power it on, and configure it manually for you. And that's what IoT device provisioning is like today. Today, when you go in and buy a mobile device, someone scans a barcode on the outside of it. And when you turn and power that device on, it goes through an automatic workflow that downloads the latest software and firmware and configuration and activates and becomes yours. And that's the problem that we're solving. This manual process is very error-prone, and so what you really want is to be able to have a plug-and-play experience where you can centralize all the logic for your device provisioning and then have that automatically applied anytime a device turns on and connects to your solution. So in an industry first, we've introduced the Azure IoT Hub device provisioning service to solve this plug-and-play solution for IoT. So the way that it works is, let's say I have multiple IoT hubs across the planet. I have one in the US, I have one in Germany, I have one in China, and there's a set of devices. What operators can do now is simply configure and provision devices ahead of time with this device provisioning service. And they can store all of the configure information there. Now when the devices turn on, they have a small SDK that points to this device configuration service. This device configuration service has a global replicated address that all devices can connect to. And when devices connect to it, what the Azure IoT Hub device provisioning service does is turn around and register those with the correct IoT hubs that's been specified ahead of time. You can even do that dynamically at runtime. Once those devices have been registered with the right IoT hub, the device provisioning service then sends the correct connection information to the devices, and the devices simply turn around and connect to their IoT hubs and become fully operational, all without any user intervention. And if you make a mistake, you can simply update the state in a central location, and then the next devices that will connect will automatically pick up that. You can even re-provision devices from one IoT hub to another one, so as devices move between areas or move between solutions, you can simply re-provision them. I'm thrilled to announce that the Azure IoT Hub device provisioning service is available in preview. You can try it out today. It supports all of our SDKs. And so all of those devices that you saw early in the device catalog, you can use with the device provisioning service. Big fan for that, yep. It's a great service. Now, managing things, once you've connected devices and built devices, it's important to be able to manage them. And there's a full IoT development lifecycle, from planning devices to provisioning them, to configuring them, to monitoring and managing and retiring. Device management is a very important part of IoT because it enables you to not only remotely control devices, remotely inspect their state, but also to be able to secure them, to be able to push down the latest security patches and updates. And IoT Hub has first-class support for device management. So the way that it works is, for all of those different devices that exist in the real world, what we do is we store a digital copy of them in IoT Hub. And we refer to this as a device twin. And what a device twin is it's a state synchronization mechanism that enables you to coordinate changes between remote devices that are always connected or even occasionally connected. And the way that it works is that you can update software, firmware, and configuration using this device twin mechanism. You can even query across millions or billions of device twins to find devices that make sense to you to operate on. And so there's a two-way communication that we set up between devices and IoT Hub that enables this state synchronization. And this is an important part, and it builds on a lot of the capabilities that we're introducing, including our new Edge support. So let's talk about Edge. Satya, this year at Build, started talking about this new focus of Microsoft's, which is to enable an intelligent cloud and an intelligent edge. And nowhere is that more prevalent than in IoT. In IoT, there's this balance between the edge of the network and the cloud. And as billions of devices get connected and are sending trillions of messages and a tremendous amount of data, it's natural that processing is going to move from the cloud to the edge and work in harmony. And if you step back and think about the waves of innovation that are happening, there's cloud and IoT, and those are very familiar now. And what each of these waves really indicates is that each wave really only reaches its full potential when it takes advantage of the previous wave. And so IoT has been around for many years. It was called machine to machine. Except with cloud now, I can have infinite scale capabilities. I have worldwide region availability, and so I don't have to stand up data centers anymore in order to deploy an IoT solution. Edge is the next evolution after IoT, and what Edge is being able to take cloud intelligence and push it right down to IoT devices and run it right down there. And then AI is a revolution that's happening right now as well. And so AI will take advantages of our new Edge platform, and we'll be able to run AI directly on IoT devices. So this pattern that I talked about before, where things are sending data to the cloud, where you're storing data, finding insights, taking actions, that still happens as Edge gets going. But what happens is you start taking some of those insights and some of those actions and shipping them right down to the device in a closed loop. Now, IoT in the cloud and IoT in the edge work in symmetry. IoT in the cloud is being used for remotely collecting data from millions and billions of devices to be able to centrally manage and provision and monitor devices. And it provides that infinite compute layer. IoT on the edge is really about where you need tight, low latency control loops. If you're using an IoT solution to protect critical infrastructure, you can't tolerate a local network drop. If someone digs up a fiber cable, you need that solution to keep running. And what's important is to have symmetry between the two, because IoT on the edge is already being used right now, except people are having to develop their own custom solutions for it. What you really want is to take that intelligence that's available in the cloud and to be able to run it right on an IoT device directly. And that's where Azure IoT Edge comes in. Azure IoT Edge is a breakthrough, industry-first new set of capabilities that are available on IoT devices, where you can take cloud intelligence and run them right there. To demonstrate this, I'd like to welcome Olivier Bloch to the stage, and he's going to show off the power of Azure IoT Edge. Olivier.
Hey, Sam.
Hey.
Thank you, man.
All right.
Good morning, everyone. So to illustrate how Azure IoT Edge will help bring that intelligence of the cloud at the edge, I want to bring you in some remote location. I'm sure some of you have seen already these pumps. They're called rod pumps, and they usually are running 24/7, extracting oil, sometimes from 1 mile deep. And they're not supervised. They're just running and running and running again without taking into account the changing conditions, temperature, pressure, what's happening downhole as well. You might have like things that have been crumbled down there. You need to eventually have sediment that need to settle. And so basically, these are not really efficient. Schneider Electric developed a solution called RealLift. So RealLift has been out there for, I think, 3 years now. And that's a SCADA system that consists in monitoring in real time these pumps by gathering data, looking at the data, and determining if something went wrong. So that actually is designed to help extend the well life, lower the cost of the operations. Another thing that is important, once again, these are remote locations, so there's no connectivity. Or if there's a connectivity, it's super expensive. So you cannot actually do more than just send a message to say, hey, there's been a problem. And so what they have to do is they have to send a maintenance crew regularly on these sites, someone that manually will inspect everything and will tell if everything is going right. And very often, they do that for nothing, because everything is all right. And when the issue occurred, very often, it's when no one was on site. So basically, they came too late to prevent loss, to prevent damage. So what Schneider wants to do is to go from that reactive system, which is already a great progress compared to the 24/7 thing, not monitored solution, but they want to become proactive. They want to implement predictive maintenance. And to do that, they started working with Azure Machine Learning. And they're creating very rich models. These models are analyzing this data. So that, what you're looking right now on the video, is 2 charts. The first one on top is showing measures on the surface. And what the RealLift system does is, based on that data coming from the sensors on the surface, it will determine what's going on downhole, 1 mile deep. So that system can be installed on existing brownfield solutions, on these very old pumps. The chart you're looking at down is the one that is important. That chart, as you can see, is very regular, a bit squarish. When the pump goes up, which is the x-axis, the pressure, which is y-axis, goes up and stays up all the way through the travel up. When the pump goes down, no more pressure. Yes, you don't want the oil to go back in the well. And so when you see that chart here, very regular, that means everything is okay. If there is a problem, like for say, a leak in the system, then you will see the chart changing shape. And that's a shape that a human can analyze. The challenge, though, is that these machines are, once again, in remote locations. And this is a lot of data. And in order to create these new machine learning algorithms, Schneider Electric needs to have the data brought back into the cloud. So the actual solution looks like that. They have what they call a remote terminal unit, or RTU, that is on-site, next to the pump. It's gathering the data, and there's a SCADA system that actually monitors it. It knows how to detect a problem. For now, it's not predictive. It's not saying, hey, in 2 months, we're going to have eventually a failure on that piece of the pump. So what it does, it sends an SMS alert to a supervision site that usually monitors several sites. Someone will actually send an operator, an expert, to go look on the site what went wrong. And they can look at these charts, these dynacards, that's the way to call them, and determine exactly what went wrong so that they can take action. Because they want to train these machine learning models, then they need to bring the data back. If they had to bring it over a wire or over a wireless connection, it would be very expensive, so very often just like copy on a hard drive, drive back. So you can imagine there's not so many of these experts that actually can go determine the problems. So there's a lot of guys going there, copying the data, driving back. So that's, not very efficient. So here's what we're going to do. Actually, what we're already doing with Schneider Electric. Next to that RTU, we're adding an Azure IoT Edge device. This IoT Edge device is controlled and monitored from IoT Hub. You still need some connectivity in order for that device to know it's in the right state. But as you'll see, we will not send all the telemetry data up. We have several what we call modules running on this IoT Edge device. So that's the notion of modules we'll describe during sessions. But basically, they are software entities you can create on your developer machine in the cloud that you're going to package in the form of Docker containers, and then you're going to deploy on that edge device to run them locally. That first module is reading from the Modbus interface of the RTU system. So it's basically able to read from one of these field buses, and it can create whatever type of modules you want. Then the data is converted through another modules to something that the machine learning model can digest. And now you see on the chart here, we have a machine learning model, an exact same one that would be running in the cloud, running on an edge device. This has been produced as a Docker container with the recently announced machine learning workbench tools and all of these. So basically, they've been training the models in the cloud. They created that model, exported as a Docker container, made it available for that edge device to download and run locally. If the machine learning detects an anomaly or predicts an anomaly, because it's able to analyze on-site a huge amount of data without having to be sent up to the cloud, it will actually trigger an alert and tell to the SCADA system, well, you might want to have someone come check it out, because in 2 weeks from now, that pump is going to fail. And the system can then send that SMS the same way it was sending it to indicate a failure. This time, it indicates, hey, we will need to have maintenance on that pump. You can see how that can optimize the process. To continue training the machine learning with real data, actually, you can also benefit for the few devices that are connected from sending that data directly to Azure IoT Hub and then inject automatically into your machine learning model. So for the demo, I'm going to show you, I'm going to be the operator. I'm going to be monitoring that SCADA system right here, and we're going to replay data from a pump. Hey, Tommy, can you help me? We're going to show what's going on here. So what we have right here is what we call a SCADA pack. So that device here is the actual solution that's running in the field that we're going to see in a second up there. Oh, you see it there, okay, on the small screen. So that SCADA pack actually is what connects to the pump, retrieves the data, and feeds it into that other black box here, which is my IoT Edge device. So it's already running the modules right now, and I'll show you how we can deploy these machine learnings in a second. So I also have this big switch here that, as you can see, indicates good or bad. This guy is replaying real data from a pump, correct data if I'm on that position, bad data if I'm on that position here, right? And everyone wants me to switch that, so I will do that. But before we do that, I was not allowed to bring a full pump. Thanks, Tommy. So what I'm going to do actually is I brought my mini pump. Yeah. I don't know why I didn't want the big full pump here. So you see here a little pump controlled by this system. So right now, it's rolling up and down, up and down. What I want to do is actually show you now, before we jump into switching to bad data, how we can get some machine learning algorithms and deploy them on a machine, and show you how simple it is through IoT Hub and its configuration portal. So what you're looking right now is the common Azure portal, and I'm looking at an IoT Hub configuration that has some IoT Edge devices connected to it. I will create what we call a deployment. Deployment is a configuration for an edge device that will indicate to that device which modules he needs to download from the cloud, install, and run. And these modules, once again, today are Docker containers. I already have 2 custom modules prepared. You see the data conversion and the Modbus one. We're missing the machine learning. I'm going to add one of the pre-cooked, I would say, modules that we have ready for you. So we have functions, we have stream analytics, and we have machine learning. So you can benefit from all the developments you've done, creating functions, creating stream analytics jobs, and creating machine learning models onto IoT Edge, bringing these very easily, exporting them as Docker containers, and making them available for IoT Edge devices. Picking the machine learning one, I'm pointing to a locally deployed container, and click OK. The next step consists in picking which devices I want to deploy to. So in a demo context, I only have one, but if I had a full fleet of these devices out there, I will want to be able to manage them and to say, hey, this new configuration has to go on all the devices that, for example, are in Florida. And I lost control on this guy. So once I selected, in that case, only one device, demo works well so far. What I can do is actually say, OK, I will go ahead and do the deployment. What's going on here behind the scene is that the deployment configuration is ready for the device to consume. Device comes online, gets the data, which is that configuration from IoT Hub, knows it has to download these various containers from a container registry, brings them down, runs them locally. So this is the only one time the device really needs to transfer data from the cloud. Once it's done that, everything is going to happen locally. Everything will be analyzed here. What me as an operator see, looking at this system right now, the SCADA system itself, is the charts on this screen. So regular, everything is going well. And what I will do is switch to bad data. And what's going to happen is that it's going to take a cycle, which is like a dozen seconds for the pump to go back and up, and then feed the machine learning algorithm with that bad data, and boom, the machine learning algorithm detected the anomaly, indicated back to the SCADA system that there's a problem. It's actually displayed here. And if everything went well, it stopped the little pump here. Everything happened on that edge device automatically. So you've seen right now how very simply I could export Docker containers and deploy intelligence from the cloud to the edge, thanks to Azure IoT Edge. We have more sessions about that. Thanks for your attention. Oops. Actually. Thank you, Sam.
Thanks, Olivier. That was great. It's great to see the power of Azure IoT Edge coming to life, and this will be available in preview very soon. Now, device security is an important topic, and I talked about that earlier. One of the things that we've learned from securing our own devices and running our own services is something we call the 7 properties of device security. And what this is a set of requirements that if a device follows this, it can actually stay secure. And we've learned this over decades. And so recently, to help the industry, what we did is we published a paper on this link here, Akka MS 7 properties. And it explains what these 7 properties are in detail. And what we're doing now is we're taking this to standards body, to the Trusted Computing Group, and we're standardizing this so that there's a well-known pattern in IoT that all device manufacturers and OS vendors can adhere to that can help keep IoT devices secure. We provide comprehensive security all the way from cloud to device with a rich set of features under each one of these. And we have some great talks this week that cover this in detail. But an important part of this that we heard from customers is a security program. And let me just explain that a little bit. Oftentimes, these IoT solutions are touched by many, many, many people, right? You'll have multiple partners that are working on it, multiple developers. And what customers have asked us is my device, is my solution secure? And unless you're able to inspect all of the code all the way from devices to the cloud, you can't really answer that question because there's a lot of customization on top that customers have done. And so what we did is we started the security program. And what the security program is a set of trusted, very competent cyber-physical security experts who are very adept at Azure IoT and Microsoft IoT technologies. And customers can contract with them, and they will come and do security audits. They will find issues and recommend remediations and make sure you're employing all of the latest IoT security technologies. Let's move to insights. Once things are connected and it's time to start finding insights from those, Microsoft has a rich set of offerings for that. You know, insights are phenomenal, and the amount of data is phenomenal that's being generated and will be generated by 2020. By 2020, 44 zettabytes is going to be generated that year alone, and 10% of that will be produced by IoT devices. And at the same time, companies that invest in this are only spending about 1/3% of their technology spend on analytics, but they're benefiting by an 8% increase in operating margin. So it's a very, very nice cost to benefit ratio here. The first part of finding insights is to discover patterns. And typically what you do is store all that data, find failure points, label those, and then use sophisticated technologies like machine learning. This week we announced a great new set of offerings for machine learning with our next generation Azure machine learning capabilities. And for average knowledge workers, what we're trying to do is democratize insights with offerings that are even easier to use than Azure machine learning. One of the reasons is this year alone, there's about 1.5 million shortage of competent data managers and analysts that the world needs. And so what we've been doing is democratizing insights and making it much, much easier. Now to explain this, IoT devices typically are sending what's referred to as time series data, where a sensor is periodically measuring something, like measuring engine RPMs every second or measuring temperature every minute. This time series data comes in high volumes into the cloud. And storing and indexing it, much less querying or analyzing it or visualizing it, can be very difficult. And so what we've done is we've revolutionized this with a new offering that can handle the scale of all of those billions of devices sending trillions of messages. Azure Time Series Insights. So Azure Time Series Insights is available now in preview. You can try it today, and it'll be generally available very soon. What it is it's a schemaless store for IoT time series insights or any time series insights. So you don't have to tell us about the shape of the data ahead of time. You simply send data and it'll infer the schema from it. It'll automatically index frequently used fields. It'll automatically provide insights to it. It enables you to store, query, and also visualize. So it's not just an optimized time series store, but it's also a rich set of UI capabilities that enable you to do ad hoc explorations and find insights visually. And it has very simple and fast navigation. It can search billions or trillions of records very, very quickly. Something that used to take overnight with long-running batch jobs to find insights can be done in seconds now. And to demonstrate that, I'm going to welcome Santosh to the stage to show off the power of Azure Time Series Insights. Santosh, welcome.
Thanks, Sam. Hi, folks. As Sam just mentioned, we have released Azure Time Series Insights. Azure Time Series Insights is a fully managed storage, analytics, and visualization solution for your time series data. What I'm going to do today is put myself in the shoes of an engineer who's working for factories, and I have been tasked with, hey, there is an issue with some production degradation in the factory. I have to go and find out across my geo-distributed factories which is the one and what is causing this issue. So for this, the first thing I do is connect all of my geo-distributed factories to an IoT hub and send all the sensor data to that IoT hub. Once I send it to the IoT hub, I can go to the Azure portal and select Time Series Insights and create an environment. In that environment, all I do is select what is that IoT hub that I am reading the data from. That's it. No other configuration that needs to be done. Once I make the selection, then Time Series Insights automatically starts reading and indexing the data in near real time. So what you will see is not just the historic data, but also the latest data which is coming with an SLA of less than 1 minute. So once that is being done, I get this Time Series Insights URL, I click on this URL, and what I see here is just the number of events per hour which has been sent from all my connected factories. I know there are some alerts which kind of fired in the first few days of my investigation, so I'm just going to select that time right now. Once I select it, I right-click and I say search. One important thing I want you to notice is over 6.5 million events were found and shown on the screen in less than 1 second. And this is one of the important things. When you're doing things like root cause analysis, you want to get this data interactively and play with this data. The next thing, I didn't have to do any configurations or data prep or anything in order to actually see this data. So let me actually see what is this? Like, what will I learn from this? I right-click here, and I see a bunch of different dimensions which are there. Time series insights is schema adaptive. You don't have to do any data prep. If your schema changes, automatically time series insights can learn from this and adapt to the schema. In here, I want to see what are all the different types of sensors which are being pushed to my single IoT hub. I've got pressure, temperature, and a variety of other information, including alerts which are being pushed. I've been tasked with some production load issues. So let me right-click production load and see what is there. Okay, let me see what is the production load by factory. Interesting. My factory 3 and factory 1 is okay, but I saw a dip in my factory 2 on 4.4 when the data was being pushed. I want to compare this with other variables which have been pushed to the same IoT hub. What I can do in time series insights is I can clone this data, and then I can start seeing what other variables are interesting for me in that same time frame. So as I had said, there were some alerts which were being pushed to the IoT hub as well. And now I can start looking at correlating two different variables on the same time axis. I see when the production load dipped, there were some alerts which were being fired. Okay, the aggregation counts are not enough. I want to be able to see what is the details here. So I can actually click on Explore Events, and I can see exactly what is the data underneath. Another important fact, every event that you send to IoT Hub is being stored and indexed here. We are actually generating all the analytics on the fly. This is one of the IP that we have here. So here I can now look at the details of the alert and say, oh, that's because of temperature. And it is in factory 2. Interesting. Let me actually look at temperature now and do some cross correlations. Why I'm showing you this is because doing not just storage and analytics, but also the ability to see this data visualize this data in the same time span is very useful for doing correlations between issues and root cause analysis. Now, just looking at aggregations is not enough here. I want to be able to see what are the outliers? What is the maximum outlier? What is the minimum outlier? Interestingly, when I had a production issue, when my alert started firing, I can see here that my temperature actually increased in my factory 2. Now, this is a way for me to quickly understand and analyze what other variables I can actually start looking at to do my root cause analysis and find my anomalies. Now, one very important thing we learned while talking to customers is there is a lot of information which is shared between different engineers and different people in an organization in order to do analysis. So I can save this query and share it with some of my colleagues. Actually, in this case, I had, and one of my colleagues did some more research and send me some data back to do my next round of analysis. And this is the data that they sent me back. They looked at all the variables that I showed you in the beginning with factory 2 and put it on the same time axis. So here's interesting. When the alert started firing, which we saw was temperature alerts, and the temperature started spiking here, let's look at pressure. No, not too much impact to pressure, not too much impact to vibrations. But here is something interesting. The temperature control unit actually started dipping before we had our first alert. What this tells me is the temperature control unit, which I was not even monitoring, was having an issue before the temperature spiked, and only the temperature was the thing that I was alerting on. So now I can go and improve the process, understand from time series insights what was causing the real issue, and start putting some alerts on this in order to optimize my production flow in the future. One last thing I want to leave you guys with is I showed you a view where I started with the charts and started looking at what is the data which was there and started exploring from the data. We found that there are different ways of exploration that people use. What you're seeing on the screen is us understanding that same data in that same time frame where I'm looking at temperature by all the different sensor IDs and putting it on a heat map. Now, what this heat map does is it allows you to visually spot anomalies much easily. Even though it is from 29 to 30 degrees, Interesting thing, 1 degree can be very important for a production line. You can easily see where you had some issues. I can right-click this, zoom into this, again, explore the events, and see, okay, factory 2 is where I need to do my investigation. So I hope what you can see in the end of this is how time series insights can help you solve your IoT problems and solutions. By the way, this is not only through the interface that I showed, we also provide APIs that you can embed in your own applications, all this rich functionality. Some of the applications are things like IoT Central or the Steelcases solution which Sam mentioned. Hope this was useful. Thank you very much.
Awesome, thank you.
Thanks, Sam.
Thank you, Santosh. And I hope you saw that Azure Time Series Insights puts deep insights into the hands of everyday knowledge workers to dramatically improve the amount, or shorten the amount of time it takes to find insights in your IoT data. So once you've found those insights, it's time to operationalize those. Like Santosh was just showing, there was a missing sensor that was missing some data in that particular factory. And for operationalizing, what that typically means is you're now monitoring data in near real time. You know what you're looking for. You've already found the insights. You simply want to start monitoring it in real time. And we have some great offerings in Azure for that, including Azure Time Series Insights, Azure HD Insights Spark and Storm. And all of these help you to operationalize insights over high velocity of IoT data. We also recently announced an update, as we mentioned earlier, to Azure Machine Learning. And Azure Machine Learning now has a rich workbench and data wrangling tools, and also exports to containers, as you saw when Olivier demonstrated being able to take a machine learning model in a container and run it right on an IoT device. And then the next process is refining. It's not enough to find insights or to operationalize those. You have to constantly refine that because data changes over time. And so we have great tools for that, including Time Series Insights is being used to refine things, Power BI to enable you to visualize your entire operational dashboard, and Time Series Insights will also enable you to take those charts and graphs and embed it right in Power BI dashboards in an upcoming wave. Now, companies are already benefiting from this. For example, Tetra Pak, which does package manufacturing, as they've applied these techniques, they've been able to cut the average amount of downtime up to 48 hours per month and saving customers over 30,000 euros on these delays. RAC, the Royal Automotive Club, which is like AAA here in the United States, was able to analyze their own fleets and dramatically reduce the amount of accidents and gas consumption that's being used and save almost $2 million a year just from using these techniques. Once you have these insights, it's time to take action and respond. And this digital transformation that IoT enables you to do a variety of things, from engaging your customers more deeply to empowering your employees to optimizing your operations. All of this is a result of taking actions as a result of those insights. And to respond, you do so in a number of ways. Sometimes that response needs to trigger a message out to a device to inform it to change its behavior. And for that, you use Azure IoT Hub. Sometimes it's to enable communication with a mobile worker on a mobile device. And for that, you can use notification hubs. And sometimes you're simply executing a business process workflow. And for that, you can use things like Azure Logic Apps. Using these techniques, companies such as Johnson Control, when they trigger an action that they've detected one of their industrial chillers, which is being used to cool buildings, needs servicing, what they do is not only are they asking a technician to go out and fix it, but they're informing the technician as they go what parts are needed in order to prevent the maintenance or prevent a operational delay of that product. And using this technique, they've been able to restart these chillers up to 9 times faster, saving over $300,000 per hour. And ThyssenKrupp Elevator, using these techniques, has been able to reduce the downtime of their elevators by up to 50%. An important part of triggering actions and taking actions is business process. And business process automation tools alone will reach $10 billion by 2020. We provide a number of services to help you integrate into existing business processes, from Azure Logic Apps to Microsoft Flow, and even Dynamics 365 and HoloLens. So for example, Microsoft ships a product called Connected Field Service. And what Connected Field Service does is it enables you to track work orders for servicing these physical assets, to be able to see details and track all of the information, including what tools are required and what parts are required to take out and service these things. And it even provides an operational scheduling dashboard, which shows all of your different scheduling engineers or technicians that go out and service these things, as well as what their schedule is. And it can automatically do all sorts of things like route optimizations and schedule rebalancing. So if someone gets sick that day and you need to compensate, it will automatically recommend who should take that trip and make sure that the right parts are on their truck in order to fix those things the first time. And one of the things that we're seeing, which is quite amazing, is a dramatic increase in the number of HoloLens deployments in IoT. And what we're seeing is that as companies realize the power of hands-free mixed reality, they're starting to equip their service technicians with HoloLens apps that are paired with their IoT solutions. As an example, all of these companies have active deployments on top of HoloLens with their Microsoft IoT solutions. And I'll highlight one, ThyssenKrupp Elevators. When they send service technicians equipped with Microsoft HoloLens, they're able to not only visualize the repairs that they need to do and see through the elevators themselves, they're able to order parts, and they're also able, using Skype in Microsoft HoloLens, to have a remote Skype assistance with people back in the back office that are often very adept at fixing certain components of an elevator, and they're able to annotate in the air right in front of them and help assist on the parts. Using this technique, ThyssenKrupp Elevators has reduced the amount of servicing time that a technician spends fixing an elevator by a factor of 4. It's an incredible amount of optimization that they've been able to achieve, and that's in addition to the 50% reduction in unplanned downtime for their elevators. So there's been a number of industry firsts. We are incredibly committed to IoT. We're incredibly committed to innovating to meet our partners' and customers' needs. And there's a bunch of industry firsts that we've done, from pre-configured solutions to having both PaaS and SaaS offerings, to solving solution provisioning at scale, to the security program and certification program, to our Azure IoT Edge breakthrough capabilities, and even OPC UA and being able to connect to on-premises industrial devices. All of these and more are helping us lead the way and provide what customers need. And all of this is going to be covered in detail this week. We have a bunch of great talks that go into a bunch of detail and explain how to use all of these so that you can get started quickly and customize these solutions to meet your need. We can't wait to see what you'll build with all of these rich capabilities, and we're just getting started. Thank you for your time.